let's define some terms, because that's going to help us actually communicate a little bit better as we start learning some of the physics. So there's a few terms to learn. Let's see, the first one is this thing called inertia. Inertia. And this one we're not going to do a whole heck of a lot with until we get to things rotating. But we can define it, because you'll see it in your textbook, as just kind of being like, how hard is it to make something go? Make something go. You'll oftentimes hear this defined as it's laziness. It's probably the more common one. A body in motion stays in motion, a body at rest stays at rest. That is its inertia. It says that if something is stopped, well, how hard is it to now get it to go? If something is going, well, how hard is it to make it stop? And the reason we don't do much with this in the beginning is until things are rotating, its inertia becomes pretty much its mass. So we'll come back to that definition in a little more detail later. Now I come to mass. Mass. And in class, sadly, we don't get to do this. We have a discussion as to the difference between something's weight and something's mass. So when I get on the scale in the morning, I don't have one because it makes me cry. When I get on the scale, it gives me my weight. My weight depends, let me write that down here, a little bit further down. My weight is location dependent. Location dependent. In other words, I am going to weigh less if I get on the same scale at the top of Mount Everest as than I do getting on the scale here in the Pacific Northwest, where I'm darn near at sea level, which, you know, is a handy diet method. You don't actually have to lose weight. You just go to a different place, you weigh yourself, you lost weight. Yay. Okay. Mass is how much something has. It's not location dependent. So I'm going to have the same mass. Mass is consistent everywhere. Consistent everywhere. So what mass says is how much stuff do you have given a unit of volume? So for my body, it's molecules and water, well, which is made of molecules, but it's the water and the muscle tissue and the bones and all of that given my height and my weight. That is my mass. I will weigh different depending on where I am. I weigh less on the moon, less on Everest than I do here. My mass, though, is the same everywhere. So you can think of that as the amount of stuff per unit volume, per volume. Let's give this some units, shall we? So my units for mass are kilograms, not grams, but kilograms. Everything we do is in terms of kilograms. And then the next one, which is really exciting, is this thing called force. Force is what I would need to do to make something that is at rest start moving. Force is what I would need to do to make something that's moving come to rest. A force is required to change the direction or the motion of something. So force can either change something's motion or the lack thereof, motion or direction. I should be more specific. That would be direction. Oh my goodness, direction. Don't even know where that spelling came from. Okay, so this would be if I had a net force. I want to be a little clear here. So this would be if I have a net force. If I don't change something's direction or motion, say I'm trying to move a car that is conked out in my driveway and I want to try to move it, but I don't have enough oomph to make it go. I'm going to push and push and push and push. And even though the car doesn't move, I am applying a force to it. I push down on this countertop, even though the countertop isn't suddenly falling down to the ground, I'm still pushing. I'm still applying a force to that countertop. What's happening there is as I push down on it, it's pushing back up on me. So I just haven't made it go anywhere. I don't have a net force, but I can push on it. So for now, let's think of forces defined in terms of things like a push, a pull. Let's see what else. Push, pull. Let's see, we could go force of tension. See, normally y'all are yelling at me to tell me suggestions that I'm forgetting. So force of tension, that would be if I have a rope attached to something and I'm pulling on it, or if you like tug of wars, you have a rope between two people and you're both pulling on it, trying to get one of them to fall over, one person to fall over. That would be the force of tension. See what other forces do we have? I have a push and I pull. I can do, as I'm trying to push my car, there's this thing that resists that push called friction. We're going to define that in pretty good detail. So friction is that handy dandy thing that keeps you on the road when you're trying to go in a straight line. Your tires have friction between the road and the tires, and that keeps you going in your straight line. Add some ice and things change considerably. So friction is our friend, but it is also something that opposes things that we want to do. If I am moving and I want to move a stack of boxes across the floor, well, friction is opposing that motion. So I have to overcome the force of friction to get those boxes to move. So let's see, there's friction. Can you think of anything else that is an action? So these are all kind of action-reaction forces. And then let's see, I said here, I weigh less depending on where I am. So this would be a force at a distance. This would be the force of gravity. Force of gravity. That gives me my weight. See, what else do I have? I have force of gravity, electrostatic forces. I'm not going to write that one down because we won't get into that this quarter. That's next quarter. But that is like magnetism and charged particles interacting. If you've done chemistry, that's ionic interactions in a chemical structure. If you have solid, it could be a covalent bond. Those are still electrostatic interactions. Those are things that we say happen at a distance, and gravity is one that happens at a distance. We're going to define how we know what gravity is and how strong it is as we move on into the quarter. The first forces that we're going to focus on are pushes and pulls. We're going to focus on those while in tension and friction. Tension will come after our push and our pull, then we'll add in friction into that. And our force of gravity we're going to deal with, but the only thing I'm going to tell you about it is that we're going to deal with it pointing towards the center of the earth. So I'm going to do some examples and explicitly talk about gravity as we get there. Let's see. So this is location dependent. And I said this thing about this net force. So there's one other thing I need to define. We'll do a different color. Acceleration. Acceleration. I'm going to come back and add units to those in a second. So acceleration is a change in velocity. A change in velocity. And velocity is a change in position. Change in position. So if I'm moving down the road and I speed up or slow down, I have some sort of acceleration. But what's important to remember here is that these are vector quantities. So changing speed, changing the magnitude of the velocity, or changing the direction of that velocity, well, that's an acceleration. So if I change direction or if I change speed, then I have an acceleration. To have an acceleration means I have to have a net force. So if I have a net force, I have an acceleration. That means I have either a change in direction or a change in velocity. So this can be direction or speed. And that's an or. So let's look at our units real quick. This is a change in position. We're going to stick with that for now. I'm going to define displacement as we move into projectile motion, and we'll come back to that. So our units here, let's see, the units here would be in, force is in newtons, and you'll get to see where that comes from. Acceleration is always in meters per second squared, and velocity is always in meters per second. There we go. Next step is applying it.